Hello there, welcome again to our Patreon tutorials. Well, today we're gonna do another workshop. This is workshop number 8 of the PAT301. This workshop has the objective of learning various methods of solid meshing. Well, basically we're gonna go around the types of TET meshing and hex meshing. So to start, as I made this new folder here on desktop that is named after what we're gonna work with. That is with a log. Um, Inside of it, we have the parasolid that the workshop gave to us at the start. So yeah, that's everything I got here. So to start, we're gonna copy the pattern shortcut and we're gonna paste it inside of our folder. Now we're gonna run pattern. We're gonna wait until it opens. Okay, there we go. Now that your pattern is open, we're gonna go to menu, file, and we're gonna create a new database. The new database, we're gonna save it inside our file that it's called log. We're gonna name the database the same, log, and press OK. And ready, our database has been created. Our tolerance, most of the time we select default, but this time we're gonna it's gonna be based on model, and the model dimension is gonna be 10. Just make sure your analysis code is MSC Master and the analysis type is structural, and we press OK. Next thing we're gonna do, we're gonna import our parasolid that I showed you at the beginning. That was the file. We go to file, then we go to import, and here we have model parasolid, and we're gonna select this one. We press OK. And we have that import summary of of the figure we just imported. So we have what the solid, the quantity it created, and everything. So we're gonna press OK, and here we go. We can see the log. It was imported. So I'm gonna select ISO view so we can have a better view. And what we're going to start, we're gonna rename our group. We're gonna go to group, then modify, and what we're going to do is we're gonna rename our default group. We click here and rename. We select the default group, and we're gonna rename it as hex 8. It's gonna be the number. We select OK, then we select apply. Well, in this case, OK. And there we go. If you want to be sure it created correctly, we can go to post and we can see here that the current group is called hex 8. Okay, now what we're going to do, we're going to create points on the log. To do so, we're going to go to geometry. We're going to select here, and we're going to select we can select either fist, but we're going to select here create point, and it's going to be by extract. Select here extract. We make sure that curve is turned on and that the parametric position is 0.5. We're gonna turn off auto execute, and we're gonna select 3 edges. We're gonna select the 2 edges that make up the outer radius of the solid and one of the back edges. So we're gonna select this one, this one. Remember to leave the shift key selected, so you can select a couple of curves. I'm sorry, let me take this off. And once we selected our three surfaces, we're gonna press apply. So we can see what we did. We're gonna make the size of the points a little bit bigger. We go to home, then in miscellaneous, you select here point size. And as you may have seen, these points were created on the front and here in the back. Okay, now we have our dots. So what we're going to do, our points, we're gonna create a plane. So to do so, we change here, instead of point, we select plane, and we're gonna, by method, we're gonna change it to 3 points. When we have 3 points, we're gonna select first, to make our first plane, we're gonna select this one. We're gonna select the one on the top, and for point 3, we're gonna select the one behind. And there we go. It was created because it had the auto execute. When you have the auto execute on, whenever you click a point, it's gonna automatically change to the next tab. And when you select the third point, it's gonna create the plane. Also, another important thing is that the first point that you select is where it's gonna refer the plane to. It's where it's gonna create. So it's very important to take it into account. Now we're gonna erase 2 because we're gonna make another plane. This other plane, the second plane, is gonna be, we want it to be here. So we're gonna select here, we're gonna select here, and we're gonna select here in the back. And there we go. We have our other plane. Now we're gonna break our solid into our newly created planes. To do so, we're gonna change here action, we're gonna change to edit, we're gonna have this to solid, and we're gonna leave it in break. We gotta make sure it is turned on the check mark of delete original solids. We turn off auto execute, and for solid list, we're gonna select our solid one, this is the whole one, and we're gonna, the breakpoint list, we're gonna select the one right here. Oh, I'm sorry. We're gonna change the option, instead of point, we're gonna change it to plane. We're gonna take off auto execute, and we're gonna, and again, I'm sorry, we're gonna select, once we have plane, we keep it delete original solids, we turn off auto execute, and we're gonna select solid list, and we're gonna select break plane list. We're gonna select the the second plane we made, plane number 2, and we're gonna select apply. Do you wish to delete the original solid? Yes for all. So as you may see, as you can see, our surface, our solid, was divided into 2, was broke into two new solids. So now we're gonna break again these 2. So now we're gonna change the solid list. We're gonna select the lower and upper, and now we're gonna cut it in the first plane we made, and we're gonna select apply. Do you wish to delete? Yes for all. And we're gonna select here refresh graphics, and as you may see, we have now our solid is now divided into 4 parts. Now we are gonna create a new group. We go here to group, we select create, and we're gonna enter the name of TET4. We select apply and then cancel. So now the group we are manipulating is TET4. Now what we're going to do is we're gonna translate our solid. We're gonna change here edit, we're gonna change it to transform. Instead of point, it's gonna be solid, and we already have it in translate. we're gonna change our direction vector to -10. It's gonna be 0 in the x and -10 in the y direction. And in the solid list, we're gonna turn off auto execute, and we're gonna select all 4 solids. We're gonna apply, and there we go. We created a new log that is gonna be on the group that we created of TET4. Now we're gonna create another group. This group is gonna be called TET10. So we're gonna go to group. We're gonna create a new one. We're gonna select it as name it as TET10. We're gonna select apply, and we're gonna select cancel. Since we already we're making the transform solid translate, the only thing we're gonna change, it's gonna be now the direction vector is gonna be 15. So we're gonna translate this solid to make a new one inside of the TET10 group. So here we go. Now we have 3. The group of the group of hex 8, TET4, and TET10. So now we're gonna post just the hex 8 because we're gonna mesh this this first log, and to be a little bit more easier, we're gonna isolate it. So we're gonna go to group, we're gonna go to post, and we're just gonna select hex 8. We select apply and cancel, and now we have it. We're gonna select here on feed view so we can see much better. Now what we're going to do, we need to make more planes, and to do so we're gonna make points so we can make these planes. So we're gonna go here to create. We're gonna make the points first. We're gonna go to extract. You remember, we have the parametric position of 0.5, and what we're gonna select here in the curve list, we're gonna select 5 edges. We're gonna select the 4 edges that make the lower half of the hole, and we're gonna do so by selecting shift, pressing the shift key, and selecting all of these edges. We got 1, 2, 3, 4, and the 5th one is gonna be an edge of the base of the solid. So we press shift again, and we select this one. So there we go. We selected our 5 edges, and we click on apply. Now we're gonna create another points. To do so, we stay on create point, but we change this to arc center. Now we're gonna turn off auto execute, and we're gonna select these 2 edges that make the hole. So we click on curve list, and we select these 2. Once we selected these 2 edges, we select apply, and as you may have seen, we made the points of the center of the hole. That is one in one side and the other on the other side. We select ISOView again. I'm sorry. Now we want to make 2 new planes, and to do so, we go to create. We change here to plane. We select 3 points. We're gonna erase this ones, first instance, and on point 1, where we want it to be the first one, is gonna be here. So to do so, we select here, then we select the point number 2, the one of the center, and then we're gonna select this one, and voila, there's one of our planes. And the other plane we wanted here, so we're gonna erase this here, points, and this one's gonna be point 1, 2, and point 3. We wanted it to go to the other side, so we're gonna do undo. I'm gonna select it again. this one. And so we're gonna choose this one now, and we're gonna choose this one. And there we go. Now it's pointing on the way we want it to be. Now we're gonna break our solids into by the new created planes. So we're gonna go to edit. We're gonna select solid and break. So it's gonna be by option, is gonna be by plane. We're gonna leave it delete original solids, auto execute off, and the first one we were gonna select is this one. We're gonna select this solid, that is solid number 4, and we're gonna select the plane that is gonna be this one, that it's plane 3. So we select apply, delete just for all, and we can click here to refresh. And we have seen there's two new solids. Now we're gonna break this solid by this plane. We select apply just for all and refresh. And as you may have seen, there's now this one is divided also. Now we're gonna create the last point that it will help us make the last plane. So we change here on create. It's gonna be point, and now it's gonna be by project. We turn off auto execute, and the point is gonna be this one. And the curve list we're gonna project it into is gonna be the one that is normal to it, that is right on top, is this one. So we select apply, and as you may have seen, there's one created right above vertically on top of the point of this point. So now we're gonna create the plane we were looking for. We select here on plane, also with 3 points. We're gonna erase these ones. We don't have any mistake. And since we want it here, we're gonna select this one as the first one, and this one, and the last this one. So there we go. We created our last plane. We're gonna break the solid one last time. We're gonna go to by this new plane. We're gonna go to edit. No, to transform. No, I'm sorry. To edit. Solid break. Delete original solid. The solid we're gonna break is this one, the big one, and the break plane list is gonna be by this one. And we select apply just for all and refresh. Now as we can see, there's 2 new solids created. Well, those were the last ones, but for now we're gonna delete the 2 top solids since they are not used for the isomesh meshing. So we're gonna also delete all the planes because they are no longer needed. We needed them just to breaking the solid, and now that we have done it, we're gonna erase them. So first of all, we're gonna go to geometry. We're gonna go, well, we're already there in geometry. We're gonna select delete, and we're gonna select solid. We're gonna select this top, go to the top, and we're gonna select apply. Refresh, and as you may have seen, there's no more of it. So now we're gonna delete plane, and since we created 5 planes, we're gonna delete all of them. We're gonna write here plane 1, 2, 5. You can also select them manually, however you prefer, but so it can become faster, I prefer this method. Like refresh, and as you can see, we just have the bottom half, and we don't have any more planes. Also, we're gonna decrease the size of the points, so we have a cleaner view of our figure. Now we're gonna refit the 5 solids so that they become parametric blue solids. To do so, we're gonna go to geometry. We're gonna select edit. We're gonna select solid, and we're gonna select refit. Once we do, we make sure that the refit parameters are all 1, 1, 1, 1. We're gonna select delete original solids. I'm gonna turn off auto execute, and we're gonna select the whole 5 solids that we got. We select apply, we select yes, and then yes for all. And now we have them all in blue. So that it will help us when we start meshing. So now we're gonna finish creating all the geometry. To finish it, we're gonna mirror or all this half, the bottom half. So, but first, we're gonna turn on the label control. And here we're gonna select solid. Once selected solid, we can see which one is the name of it, the number of each solid, and we're gonna make big again our points. After that, we're gonna go here to transform. There's our form. We select solid, mirror. Here we're gonna make sure it's turn on reverse solid. We're gonna select here in define mirror plane normal. We're gonna erase. We're gonna select this option, 3 points for the plane. And what we're going to do, we're gonna select 3 points in this plane. Make sure to not select with shift press with the shift key selected pressed like in other commands. In here we're just gonna select it without pressing the shift key. I'm gonna select this one, and this one. It can be either 3 of in this whole plane. We're gonna reverse solid gotta be turned on. We're gonna select the solids. We're gonna select all of them. Oh, we selected twice. We're gonna select all of them, and we're gonna select apply, and there we go. Now we have our whole geometry finished. So now we're gonna create a new group. We go to here, group, create, and this new group we're gonna name it hex 20. This is gonna be our last group we're going to create. We select apply and cancel. When finished, we're gonna translate the geometry. We go here to transform, mirror, translate. Here in translate, our direction vector is gonna be 15 in the x direction and 0 in both of the other ones. On the solid list, we're gonna select all of the new ones, and we're gonna select apply, and there we go. We have our whole new group. So with the new with the same solids. Now we're gonna go to group, and to view all of the ones we have created, we're gonna select all, apply, and cancel. And there we go. We have all of our 4 groups, which we can view them. This is one of them is called differently. This one is, if you remember, this is hex 8, this is hex 20, this is TET 4, and this is TET 10. So now what we're going to do, we're going to create a cylindrical coordinate system for the hex 8 model. This coordinate frame will later be used to apply a radial pressure. So what we're going to do first, we're going to go to geometry again. Wait a second, we're going to go to geometry. Then in geometry, we're going to go to create, coordinate, and we're going to select 3 point. I accidentally pressed a key. We're going to turn off auto execute, and here we're going to change rectangular to cylindrical. After that, you can leave auto execute turn on, and what we're first going to do, so now what we're going to do, we're gonna select here, we're gonna turn off the labels, and now so we can work better, we're gonna just zoom in on the hex 8 group, because this is the one we're going to work first. We're gonna the origin we're going to select is this point, the one in the back, in the center in the back. This is gonna be our origin. The point on axis 3 is gonna be this one, and the point on plane 1, 3 is gonna be the one that is right on top. So you can view better, it's gonna be the one that is right on top here, this one. And once we have done it, as you may see, our coordinate system, oh well, we have a problem. It was turned in the other direction. We're gonna undo. We want the T to go in the other direction, so we're gonna do back, undo, and I'm sorry, now I know what I did wrong. I accidentally selected another point, so we gotta be careful. The one we're gonna select first, origin, is gonna be the one of the back. Next one on point on axis 3 is gonna be the one that is right in front of it. It's still on the center. We select this one, and point on plane 1, 3 is gonna be the one that is right on top of the front one. It's gonna be this one, and there we go. That's how your plane, your new coordinate, gotta look this way, as indicated, as you can see it on screen. So now what we're going to do, we are going to mesh. We're gonna mesh our hex models. So we're gonna start with hex 8. So we're gonna start by posting just the one we're gonna use, that is hex 8, apply, then cancel. We're gonna fit it in, we're gonna select the isometric view, and now we're going to go to meshing. Once on meshing, we're gonna select mesh, solid. After solid, we're gonna select here, we're gonna select hex, we're gonna select isomesh, and we're gonna select hex 8. On solid list, we're gonna select the whole solid. Once selected, we're gonna turn off automatic calculation. Here, the workshop suggests us to use the value of 0.5, but since we got a student edition and we have a limit of total nodes that we can do, we're gonna round it up to 1, so we can make the nodes for all our models. So we're gonna select 1, and we're gonna click now on apply, and there we go. As you can see, it's nearly meshed. As you can see, we're gonna turn on the nodes. We got one node. It is at the edge, or on the vertex of each one of the entities that make. Pretty cool, huh? So now what we're going to do, we're gonna mesh our other group. We're gonna go to post, we're gonna turn on the hex 20, and we're gonna click on apply, then cancel. We're gonna mesh this one. We're gonna do pretty much the same. Yes, it's going to be create mesh solid, hex isomesh, and the topology we're gonna change it to hex 20 instead of hex 8. The solid list is gonna be this one, and automatic calculation gives to us is gonna that is 1.5. We're gonna round it up to 2, and we're gonna turn off this one, and we're gonna click on apply, and there we go. As you can see, the great difference about hex 8 and hex 20. As you can see, in hex 20 we got this little nodes in the middle of the vertex. In the other one we only had on the vertex, if you remember, but here we got in between, so that makes it a little bit a more finite meshing. So now what we're going to do, we're gonna mesh our other solids. We're gonna go here on group, we're gonna select post, and we're gonna start with TET4 now. We're gonna click on apply, cancel. We're gonna go to fitted view. Well, we're gonna zoom manually, and now we're gonna change here. We're gonna select TET. We're gonna select TET mesh, and we're gonna select TET4. Our solids, we're gonna select them all, and automatic calculation gives to us that it's gonna be 0.86. We're gonna round it up to 1. And now we're gonna click. Also, the workshop suggested that we change assembly parameters, but since the student edition doesn't let us, we're gonna leave it that way. And now we're gonna click on apply, so the meshing starts. And there we go. Pretty cool, huh? You're gonna notice something quite similar. The difference of this TET4 and the TET10 we're gonna create. So observe it real good. And now we're going to mesh the other one. We're gonna go to group. We're gonna go to post. We're gonna select TET10. We're gonna click on apply. After this, we're going to zoom in, and now we're gonna click on cancel. The input list is gonna be this new solid. TET4, we're gonna change it to TET10, and the automatic calculation gives to us that it's gotta be 1.7, so we're gonna change it to 2. Round it up to 2. We're gonna click on apply, and as you can see, it's pretty much the same difference. Here on the TET4, we only got it like in the vertex, and now we got them also in between the edges. So that makes also a more finite mesh. Now what we're going to do, well, we are gonna post the 4 groups. We're gonna go to post group, post, select all, and apply. And now we can see the 4 groups. I'm gonna turn off the notes so we can see a little bit better. Now we're going to verify. We're gonna verify our new mesh. We're gonna go to create. We're gonna go to verify, element, and then boundaries. We're gonna display the free edges. Click on apply, and where we are seeing the yellow lines indicate the element free edges. Here the elements are not connected. So the tool we're gonna use to change this, we're gonna go to equivalence. We're gonna keep it as all tolerance cube, and now what we're going to click on, we're gonna click just and apply, and there we go, it's already done. So to verify what we've done, we're gonna change here to verify, element boundaries, apply, and as you can see, now we don't have the free edges of here disappear. We only have these free edges that these ones are the desired free edges. So it worked how we want it to be, so that will help us continue to our next point. What we're going to do, we're gonna copy the coordinate system we did here on hex 8. We're gonna translate it to all of our models. We're gonna go to geometry. After geometry, we're gonna go to transform. We're gonna go to chord and leave it as translate. Our direction vector is gonna be 1500. We're gonna select the coordinate frame list. We're gonna change it to, I'm sorry, this one we're not gonna change it. Which one? The one we're gonna change is direction vector. We already changed it, and we're gonna select here, instead of auto execute, the coordinate we're gonna select is the one we created. There's gonna be this one. So we select apply, and as you can see, already translated to the one of the right. So now what we want is to translate them to one of the ones of the bottom. We're gonna select here instead. We're gonna change it to 0, and we're gonna change it to -10. And for coordinate frame list, we're gonna select the both of them. This one, sorry, it's selected both times. So we're gonna select this one and shift select the other one. And when selecting both, we're selecting apply, and both of them translated simultaneously. So now we're gonna create a field for each pressure loading. We're gonna click on the shaded button so we can see a little bit better. Whoa, pretty cool. We're gonna go to loads BC. We're gonna go to create. We're gonna go on to a spatial. I'm sorry, to pressure. I'm sorry. I'm real sorry. First, I got a little bit confused. We gotta first make the fields for each one of our models. We're gonna go here on LBC fields, create a spatial. We're gonna create a spatial, and this one's gonna be PCL function. When selected that, we're gonna name as field name. We're gonna select the first one since it's gonna be for hex 8. We're gonna select sin pressure underscore hex 8. And once that, we're gonna select the coordinate system, and the first one is gonna be this one. The scalar function we're gonna create is sin r parenthesis apostrophe and t and t. Done that, we're gonna click on apply, and fields and pressure hex 8 created. Now we're gonna create for the rest of the models. So here hex 8, we're gonna change it to hex 20, and the coordinate is gonna be coordinate number 2. We're gonna leave the same function, and we select apply. Now we're gonna do it for the PAT301 coordinate system. Gonna be this one, and we select apply. Then it's gonna be PAT10 coordinate system. Gonna be this one, and we click on apply. And there we go. Now we created our fields. So now done that, we're going to go to the pressure to create the pressure. This one is for this one's temperature, pressure, create pressure element uniform. We're gonna name it for the first one. It's gonna be hex 8. And after that, we're gonna click on input data. And in input data, what we're going to we're gonna select the sim pressure hex 8 first, and the scale factor is gonna be of 1000. So now we're gonna select on OK. We select the hex 8, and we're gonna select here. What we're going to select is select the application region. The solid faces are what we're going to select is the left half of this of each of the models. So for the ones of hex, what we're going to select is we're gonna shift select the 4 faces that make this half. That is this one, this one, this one, this one. And as you can see, we selected the half of them. We are gonna click on add, select OK, and we click on apply. And there you go. Now we can see our pressures, our new created pressures right here. Now we're going to create for the rest of our of our models. We're gonna go to the hex 20, the one on the right. We're gonna change here hex 20 and input data. Now we're gonna select hex 20. We select OK. And select application region, and we're gonna shift select all of this. Select an add, we select OK, and we click on apply. There we go. Now we're going to go to the next one. As you remember, this is TED4. Here in TED4, we're gonna change his name, TED4, input data, TED4, select OK, select application region, and in TED, as you can see, instead we're gonna shift select to select the half, the inner half side of that hole. We just need to select the surface, two solids, and we click on add, and we're gonna select OK. Then we're gonna select apply. Now we're gonna create for the last one that, as you remember, this is going to be TED 10. We select TED 10 and input data. We're gonna select TED 10. Click on OK. Select application region, and we're gonna shift select this part and this part. We select an add and OK. Once we're gonna select on apply, and there we go. Now we're gonna select on fitted view, and as you can see, this is the way it should look your four models in this way once the pressure have created. Now what we're going to do, we're gonna create the constraints on each model with just one constraint set. To do so, we go to load BCs, load and boundaries constraints. We're gonna go to displacement constraint. As you can see, create displacement nodal. We're gonna select here constraint. We're going to go to input data. We're gonna select on translations. We're gonna 0, 0, 0. We select OK. We're gonna select application region, and we're gonna select the surface. This is geometry. We're gonna select the surface or face icon, and once selected, we're gonna shift click the back faces of all the models. As you can see, it's gonna be this way. We're gonna click shift, and we're gonna select all this, the backs of all the models. Select OK, and we click on apply. Yeah, yes, and there we go. Here is now the constraint became in what just constraint said. It got constrained all of our models. Now we're gonna create the material properties for our model. We're going to properties, isotropic. We're gonna put the material name of aluminum. We go to input properties. We're gonna select as elastic modulus 10e 10 to the 6, and we're gonna Poisson. Poisson ratio is gonna be 0.3. We select OK. Then we click on apply. Now our material has been created of aluminum. Now we're gonna go to 3D property solid. The name, we're gonna name it after, well, we're gonna name it as solid. We're gonna input properties. We're gonna select aluminum. We're gonna click OK. And select application region. We're gonna select all the members, all the solids. We're gonna click it on add, and we're gonna click OK. and apply. So there we go. It was created. Property set solid created. Now what we're going to do, now we're going to check the load case. To do so, to see if all of our forces and constraints created properly, we're gonna go to load cases. Here we're gonna change it, instead of create, we're gonna change it to modify. We're gonna select the default, and we're gonna make sure that everything is right where we want it to be, is the one of the constraint and the pressures of the 2 hex and the 210. So that makes it that it's okay. So once done, that's really good. As you can see, even though there are 4 disjointed models in the database, the 4 we made, MSC Pattern views them as one model. It will solve it as if it was one model, as long as each model is correctly defined. So we're gonna click on OK, and we're gonna leave it like that. Now what we're going to do, we're gonna send to run the analysis. We're gonna change it here on analysis. Entire model. This is, we're going to change it to analysis deck. The job name is gonna be lug. The translation parameters, we're gonna change the card format to small. And now we're gonna make sure now that the solution type is linear static. There we go, it is. We select OK, and now we can put it to run. We click on apply. And it was made, it finally made. So we go and check our folder, and as we can see, here we go. Here we have our BDF file. So now we're gonna put it to run. We're gonna go to MSC Nastran. We're gonna open it. We go to log. Wait a second. Why did I'm sorry. This is documents. We're gonna go to desktop, log, and here we have our BDF. We're gonna click on open, and we're gonna click run. And we're gonna wait for the model to finish running. So to know when it is finished running is when this new dialog box disappears. It's already running. As you can see, there's a lot of new files, but it is still running. And there, it finished. As you can see, it created our XDB file. But first, we're gonna see if our lug, if our FO6 doesn't have a fatal. We're gonna run the notepad just for this time, and we're gonna look Control F, and we're gonna look for the fatal message. And we didn't find anything, so that means it's good. We're gonna check for a warning also. And after the first one, that is the copyright law, it doesn't have anything else, so that means that's real good. So now what we're going to do, we're going to go to pattern again, and we're going to attach our XDB. To XDB, log name, select results file, and we're going to select lug. We click OK. So now we're going to click on apply, and it's attached. As you can see, attached result file. So now we're going to go to results, and we're gonna see the magic happen. We're gonna select the default A1 static subcase, and we're gonna select the displacement translational. Once selected, I'm sorry, instead of quick plot, first what we want to see first is the deformation. We select here in deformation the A1 static subcase, and we're gonna select the displacement translational. Now we're gonna click on apply, and as you can see, it's pretty hard to see this way because of the shape and geometry posted. So we're gonna unpost them all, both. We're gonna go to the display attributes. The display attributes is no, this is target display attributes. We're gonna uncheck. We're gonna uncheck this one, the show title, and show maximum label. Well, I'm gonna leave this one, but I'm gonna uncheck the show undeformed. Now I'm gonna click on apply, and I'm gonna go to plot the right click, plot erase, and I'm gonna erase the geometry. So now we can see it a little bit much better. As you can see, we can watch the deformation, how it created. All of them the same log, same pressure. But as you can see, here's the difference, how we can see the difference of each mesh. This one suffer a little bit more, less deformation, and this one's have the pretty much similar deformation. Pretty cool, huh? So now we're gonna plot the von Mises stress for each of the models. We're gonna go to, we're gonna click OK here. We're gonna create. Now we're gonna go to French, and what we're going to do is we're gonna select here. We're gonna select the stress tensor. We go to the last one, and we're gonna click on here and apply. And as you can see here, we can see with the colors, we can see all of the stresses, and in which part the log suffers the highest stress. This one is with color red. To see it a little bit better, you can see this one that is on the center, as you can see. Note that it is somewhat difficult making a comparison between each of the models because each model is reference to the same color bar. So what we're going to do in the next steps, we're gonna assign an individual viewport to each model. This will allow us to make a much easier comparison between each model. So what we're going to do first, we're gonna go to viewport. We're gonna select modify. We're gonna click on rename, and we're gonna write the name hex 8 under remain as. Now we're gonna click on apply, and we're gonna click cancel. Now we're gonna go again to viewport. We select create, and the new one is gonna be hex 20, and we're gonna click on apply. We're gonna create the same for TET4, and we're gonna create another one for TET10. Okay, now we're gonna click on cancel. We're gonna go to viewport, and we're gonna select tile. As you can see, there should now be 4 separate viewports. So now we're gonna post the coordinate frames. We go to display, and now we're going to go to coordinate frames. After that, we're gonna select unpost all. Once done that, well, we're gonna select OK, and now we're gonna select the hex 8 viewport by clicking on it. Once clicked on it, we're gonna go to group. We're gonna go to post. After selecting it, we're gonna select the hex 8 group and click apply. And now we're gonna go to. Now we're gonna do the same for each of the viewports. So we created this for hex 8. We're gonna do it now for TET4. In TET4, we're gonna select TET4 and apply. As you can see, hex 8 now has hex 8, TET4. Now TET10, we're gonna select, it's already TET10. We're gonna click apply again to make sure. And hex 20, we're gonna select hex 20. We're gonna click on apply. And now once all of each one of them has its corresponding, we click on cancel from the group dialog. So now we are gonna create, we're gonna plot or the displacement and the stress for each of our viewports. First, we're gonna select hex 8, making it the current by selecting, click on it. We're gonna go to deformation. Once done that, we're gonna select the displacements translational, and we're gonna click on apply. Once done that, we're gonna go to fringe, and here in fringe, we're gonna select the stress tensor, and we're gonna select, make sure it's bond misses. We're gonna click on apply, and since it was already done, we cannot see it quite much, but you can see, we can now see the which one is the lowest stress, and which one is the highest. It's 3.95 times 10 to the 3 that it's on the top part, on this red part. So we're gonna do this for each one of our viewports. We can now go to this one, TET4. We're gonna make it current by clicking on it. We're gonna select deformation, displacement international, and we click on apply. Now we're gonna go to fringe. We're gonna select the last one, stress tensor by von Mises, apply. As you can see, there was quite a difference. The lowest one, as you can see here, a little bit, is 4.6002, 460, and the highest one is 2070. That, as you can see, is on this parts. Now we're gonna make TET10. We're gonna select deformation, displacement translational. We select apply. After that, we're gonna select fringe. We're gonna go to the last one, stress tensor by von Mises, apply. You can see there's quite a difference from this TET to this TET. And here in TET10, we can see that we have the lowest one is 680 and the highest one is 4,190. Remember, these ones are both made on TET, but this one has TET4 and this one's TET10. And as you can see, there's still quite a difference. We make hex 20. We're gonna go to deformation, displacement translational. We select apply, and now we're going to fringe. We're gonna select stress tensor, von Mises, apply. And here you go. Now we can see that is 617 the lowest, and 4,310. A quite difference between the other hex. So you can see where the stresses are concentrated. It's on the red part. So what I want you to see is note the similarity between the results for the hex meshes and the TET10 meshes. These hex have quite a similarity, and the TET10, as you can see, they're pretty close, but the TET4 is very inaccurate. It's pretty much far away from all of the others. So it's better to not use TET4. And also another thing to note is, as you remember, in the TET mesh, we didn't have to break it a lot, the model, to mesh it with TET. So the TED mesh is a very convenient approach because as I was saying, it is not necessary to break up the solid into many parts like for the hex we had to do it. So that was it. Thanks a lot for this staying this video with us. Hope you like it. Hope it helps you, and thanks a lot for everything. If there's any comment or suggestion, uh, be, uh, be feel yourself invited to leave it right below. Also, if you like it, you can subscribe to our channel and give us a thumbs up. Thanks for everything. See you soon.